So before presenting an example of the cross-site scripting, which is, by the way, already ready on the GitHub website of this course, I want to introduce you an API that we are going to reuse sorry, a lot also with React. So it's not something that we are wasting, but we are actually using it, writing it in the code supporting our React application. That is the fetch API. Okay, so how we load, request information from a web server from the JavaScript code running on the client. Okay, so so the situation we have currently is this one. We have a client part, the client application inside the browser, okay, the blue external rectangle, that is running JavaScript code. So there is a JavaScript interpreter, JavaScript code. The JavaScript code is handling the user interface. We saw before that we have a function that can create, destroy, add things in the DOM. So they can change things in the appearance of the application. Okay? But we are still missing a link here, the question marks, right, to the server. So how can we say from our JavaScript code, go and load the information from the server regarding the list of answers, the films that you have in your lab application, and so on. Okay? We have no ways of saying, okay, go and load this URL. On the other side, on the server side, we have almost all we need, right? Because we already saw it from the beginning of the course. We developed it in JavaScript, and inside the node environment, we are able to run actually a complete server application using the Express library that handles the HTTP protocol for us and gives us the possibility to add event handlers in the forms of callbacks that can answer to specific HTTP methods. You remember the app.get, app.post, put, delete, and so on with specific URLs. Okay? And then we can connect that to a database to make the data persistent and so on. That's fine. So basically, the API server is sort of ready. But the point is that we are missing, not the link, because we already tested it. We have the REST client or the browser can test these connections. But the point is here. How can we start a new request towards a web server, a certain URL of a web server that for us, for our application, it will represent an endpoint that returns data or stores data, handles data? Well, at the moment, we have no way, right? And we need to be able to execute HTTP calls. So we would say in English, to fetch something from the API server. Okay? That for us is also the web server. Web server, the first time we access it, because it returns the web page that contains everything that is needed to start working with the application. And then it's an API server because it has other endpoints that returns content, so JSON encoded content. So there is a special API provided by all modern browsers that is called fetch. Okay? It's really the name of the function to be called. Window.fetch, window can be implicit, so we can just write fetch inside the browser. Okay? Of course, we need to tell the function which URL we would like to load. Okay? So we need to pass a URL. /API/get all answers, okay? Or http/www.polito.it and so on, okay? Of course, we will have some restriction. We cannot really load anything you would like, but that's for later. So we need the URL of the resource, and then we can specify how to access the resource. So there are different HTTP methods and so on. The default HTTP method, if we don't say anything else, is the get, just retrieve the content. And since it's an asynchronous operation, the fetch has been designed so that it returns a promise. Okay? That's why we also insisted so much about promises. It's a good concept for JavaScript because it's heavily asynchronously based programming language, but also promises are objects that are returned by library functions, so we need to be able to use them efficiently and correctly, okay? So fetch returns a promise. The promise will resolve once the load operation from the server is finished, in a way or in another way, okay? At a certain point, the browser decides that it got an answer, and so it will resolve the promise inside the JavaScript environment that made the request, okay? So the promise can be set either in fulfilled or rejected state, right? So, and we will see what happens here. So it resolves to the response object, so there is a specific type of object called response. We will see the attributes in a minute, that contains all the information that we got from the server, okay? So especially the body part, that is what we are typically interested in, okay? All the details of the HTTP transaction, the content and so on. The promise is rejected, might be rejected, only in case of network errors. That doesn't mean if we didn't find the content. I mean, 404 content not found, it's a fulfilled promise. It resolves to a response object that contains an empty body and a 404 status code and so on, okay? It's a fulfilled promise. If there is a network error, so basically it takes a while and we cannot connect to the server, in short, that's a typical example, the promise will be rejected, okay? After a certain amount of time, because it's a network connection. You need to open a connection, wait for the response, and so on, okay? It's an asynchronous operation, and indeed, implemented in this way, you call the fetch, you immediately get a reference to an object that is a promise object, and your code can continue executing in the other operations. So you don't block the browser, you don't block the user, you don't block the user interface, okay? And when you get the response, the promise will be solved, and you know how to handle a resolved promise, okay? Then, or you make await with the result, and the code will resume the execution from that point when the promise is resolved, okay? Just keep in mind that the promise is rejected only in case of network errors, okay? So typically in our applications, this will never happen because we control the server. The server is on the local machine just for convenience, and so there cannot be any network error. The only moment at which, I mean, the fetch doesn't work if we didn't start the server, okay? But I mean, this is really a limit situation, so I mean, not really so needed to. No need to handle it on the client side, okay? The other reason why you might not get an answer from your server is the server crashed. But I mean, the bigger problem is that the server crashed, not that you cannot connect to the server, okay? So, I mean, typically it shouldn't happen in your test applications, okay? But in actual reality, yes. I mean, we connect and we lost the Wi-Fi signal. We disconnected the cable. The internet was broken somewhere, and we cannot connect to a certain server for some reasons, okay? How to use the fetch? Just handle the promise. You know how to handle the promise. Then, so fetch a certain URL. Can be absolute, so with the host name, can be relative, and so on. We will see examples later. And then .then, and this is the callback to be called when the promise is resolved. Okay, so when you get a response from the server, you know that you pass a callback that takes one parameter, that is the value of the resolved promise. Okay, so this is the response object. We're going to see it in a minute. You use it, and you will discover that for our convenience, it already includes some methods like .json that can parse JSON format. Okay, it's very, very, very convenient. That's why so many applications use JSON format nowadays. It's compact, it's human readable, and it's also very convenient to use while programming the application. And then the then again returns a promise. So you can chain other operations as you like. You can, of course, this is just console log, but you can use the object that has been reconstructed by the JSON method in your application, extract an array, whatever, the list of films, the list of answers, whatever you need. Okay? Or if you prefer the await syntax, you can simply await for the fetch. You know that this code will stop here, but will allow other functions to be put into the callback queue and then be executed as needed. Okay? In particular, the events that the user generates while interacting with the application. So the application is not blocked, it's just, I mean, the browser has another thread, has another mechanism that allows to wait for the response from the server. When you get a response, you get this resolved promise, and the response object is the return value of the await, as usual, with the promises, and then you can do whatever you want, again, on the response object. Response JSON, I already told you maybe, but today we will say again, the JSON method returns another promise, so you can, I mean, you must await on this value because it's a promise, as we did before. I mean, this was sort of implicit because there was a then that in any case returns a promise. Here, JSON returns a promise, so await data is just the JavaScript version of the data structure contained in the JSON. Okay? So it's up to you to decide which syntax you prefer. Of course, here on the right, we didn't handle the rejected promise. Okay? We didn't do it either on the left, but here is .catch, and here it looks much cleaner, but if you want to handle the rejected promise, you need to have a try-catch block. Okay? But again, the rejected promise, at least in the beginning, we shouldn't care about it because it's just when you cannot connect. Okay? There is a network issue, network connection problem. So what does the response object contains? It contains a lot of properties. Well, .ok is a boolean if the HTTP status code is between 200 and 299, so it's in the series of OK codes. So everything went fine. So basically, we can just test the .ok to know if there was a problem or not. If there is a problem, we can also test the status code to check for the value of the status code. You remember the 404 not found, the 500 internal server error, 422 was object not correctly formatted. I don't remember the string, the actual string of the standard. But I mean, we can test for situations that we identified on the server side. And remember, in our case, we decided which status code we want to return from our API. So we know what the API does when something happens, and we can check it on the client side. Okay? If you don't develop the API yourself, well, you have a look at the documentation of the API. Or you try. Okay? Headers, in case you need the headers. URL, the final URL in case the server has done redirection and so on. But I mean, these are not typically used so much. And there is the body, which is a readable stream of the body content because, I mean, the promise resolved as soon as it gets the first bytes of the body. Okay? It can be a big body, but I mean, we don't really want to care for these limit cases. Also because we don't really want to care about the format of the body, and we want to use directly, where is the, a JSON, okay, method that we saw before that does the parsing of the content for us and simplifies a lot of things, including handling this stream of data that comes from the server. Okay? So, back one step. So you can access the response header. This is mostly just if you are curious. You see that when we have an HTTP transaction, I just did some tests during the break, right? So there are response header, right? So accept, cache control, connection, content type, etc., etc. You might want to have a look at these headers, and you can do it with the fetch, okay? I mean, this is just for debugging, for instance. You may want to handle the errors, and the errors are handled basically by the status here, the status attribute of the response object. So, suggested error handling approach, well, first of all, maybe you can check the .ok attribute. If it's fine, probably you don't really care that much of the status code. If it's not okay, maybe you want to have a look at the status code. You might want to check the content type header. It depends a lot on the application. In our application, it's basically application JSON, so always JSON. So probably there's no need to check this if it's JSON or not. I mean, also because this is just something saved from the server. Actually, what we can do is just parsing the content as if it is JSON, and if it works, that's fine. And provide a catch for other types of errors, okay, but we know that the catch works, I mean, is executed only in case there are network connection problems. Example, okay, fetch a certain URL, then the response. If response not okay, do something. That's on the client side, so we need to decide what to do. I mean, if it's normal for the application, maybe we just ignore it. If we say, well, it was not found, maybe we want to show something in the client application. So create a new DOM element that says a paragraph not found, and not, I don't know what you want to do with the application. With React, of course, we will go into more details. We will set something that will appear in the application and so on. Okay, and then type response get headers get content type. Okay, type is not application JSON. Maybe you want to say something again. Return response, etc., etc. Okay, so that's a possibility how to handle the response object that is the object that is returned by the resolved promise returned by the fetch. Okay, here we just throw things because I mean, we have no other code, so programmers are lazy. Just throw exceptions that will be taken by the catch at a certain point somewhere. Okay? Okay, fetch options. The fetch can be used to send GET requests, but also POST, PUT, delete, all the HTTP methods. Okay? But if you want to say that you want to use POST, for instance, you need to specify an additional parameter, not just the URL, but this additional init object that contains important fields, important attributes, for instance, the method attribute, the headers you might want to add, and we will have a method, a header that we will always want to add when it is not a GET, that is application JSON, when we are sending some information in the body because we want to exchange JSON information, JSON encoded information. And of course the body. We want to send something in the body, post a certain URL, and you have a body. Where do you put the body? Again, in the init object. There is an attribute where you can put the content of the body. Plus other attributes that we will see when needed, especially like credentials. Okay, when we have authentication, we need to send the cookies and so on. But that's for later. So post. Let's take a post, which is a bit more complex than the GET, sorry, with the JSON content. So we have an object to send. Any object can be an array, whatever you want. Even a single number, a single string, it's fine. Anything can be encoded in JSON, right? So fetch this URL, and then you open the curly bracket, you create this new init object, and you set the method as a post, just string post, P-O-S-T. Headers, content type application JSON. Don't forget the headers here. It's important. It's an object because you can have more than one header. But for us, one header is enough. And this is important because on the server side, the Express JSON middle will look for this header. If it finds this header, it kicks in and it works and it parses the content in JSON format and understands it and makes it available to the rest of the callback on the server side. So don't forget the headers, content type application JSON in this case. And the body, you need to convert this object or whatever into JSON format. Very simple, because there is a function, library function, that can do it. JSON, all uppercase, .stringify. Okay? This is available in the JavaScript environment, so you don't have to import any libraries, packages, and so on. Okay? So, pretty simple, I would say, right? If it's just a get, URL is fine. Oops. If it's not a get, you need to specify method and headers and body if you need a body. Okay? Catch, just to handle, I mean, of course, here the then is missing. You would need a then probably to handle the response in case there are no problems. Or catch, okay, fade, whatever. I mean, but this catch is executed only in case of network errors, okay? Otherwise, you need to then and decide what happened on the basis of the HTTP status, as we said before. Okay, so how to read the body? I told you, I mean, we are going to exchange data in JSON format. And the point is that the response.body, I mean, is a bit cumbersome to use. It's a bit inconvenient, okay? Because it gives you a readable streaming object. It's not a string, okay? Because it might take a while to get all the information from the server, and you want to notify the application as soon as you receive the first byte. Think like you need to download 1 megabyte of data from the server, because this API returns all the films of a certain year. I don't know. It's a 1 megabyte set of data. Okay, and so you don't want to wait for downloading everything and then notifying your JavaScript code that you downloaded everything. Okay, so that's why they designed the API in this way. But from the practical point of view, for us, how do we use it? Well, the best way to use it is just use some other methods which are provided on the response object. But the point is that we can use just one of them, okay, just once. One of them just once, one time, okay? So either we get it in the format of text, so plain text as a string, which is not typically what we do, or we can assume it's JSON and ask the response object to take everything, so wait for everything, parse it as if it were in a JSON format, and give us a JavaScript object that corresponds to the JSON representation of this object, okay? And that's actually what we are going to use. .text is just for testing. I mean, I put it here just because sometimes you want to do a quick test, and on the server side you do send a string, and on the client side response.text, and you can do console log and easy, right? And the rest is more complex, is again for more complex object, binary data, and so on, but I mean, we're not going to use it in our application. Just for convenience, I mean, everything can be done, but again, we need to shrink the course into 8 credits, right? So try not to do useless things, okay? And of course, if you are curious, there are the labs, just ask me during the lecture, I mean, maybe in the breaks and so on. You can do more than one fetch. Fetch is just an asynchronous function, right? It returns a promise. So once you load the resource and you discover you need something else, run a fetch again. Do another fetch, okay? That's fine. I mean, const response await fetch users JSON, list of all users, okay? We identify the first user in the list, and regarding this user, we want to have some additional information. Again, another fetch, okay? As long as you have the APIs and you know which APIs are exposed by the server, that's fine. I mean, just run a fetch and you make a request towards the server to a certain API with a specific URL using a certain method. In this case, it's implicit, it's a get request, okay? And it's a get method, a get HTTP method. And just for simplicity, again, we decided that in our web application, all the information will be exchanged in JSON format. Okay, so we always do .json for our convenience, for simplicity, and also because it's very common nowadays. If you look at the APIs, also the Polito API somewhere, in many places, they return JSON content, okay? Because it's very convenient. You can compress it automatically, by the way, okay? It can be done automatically, interacting with low level from the server and the client, okay? So using a text format is not so heavy in a certain sense, also from this point of view. So you don't really need to exchange binary data just to be more efficient, because again, you can compress the content quite easily on the server side, transparently, okay? Okay, these are sequential fetches. So fetch, you want to wait for the result, and then you issue a second fetch in the client code, okay? It's quite normal. I mean, I want a list, and then I decide what to pick from the list and ask for more information about one item in the list. It's like I read the list of all students enrolled in the course, so first action, get the list, and then I'm interested in one student, click on the student, and I issue a second fetch, okay? And so I want to first fetch to be completely processed, and I want to have the whole set, I mean all the data that comes from the server before issuing the second fetch, okay? In this case, we pick it directly. It could be a user event, click on some items in a list and so on, that issues the second fetch and so on. If you put a wait, you are sure that when you get the response object, there is a response coming from the server, and after the second wait, you are sure that you received all the content from the server, okay? Because the response JSON returns a promise again, okay? For two reasons, basically, because it accesses something that might not be finished yet, that body that we said before, and the second is it might take a little bit of time to parse a complex JSON, okay? So they didn't want to write a blocking function, so it returns a promise, and the promise is resolved with the JavaScript object when the parsing is finished, okay? Good. So sequential fetch is probably the most common case, but you might want to have parallel fetches as well. I mean, there's no reason why one fetch should wait for the previous one. I mean, you're issuing requests maybe from different websites. That's one possibility. You're issuing requests towards different APIs, list of students, list of courses. I mean, they are independent. I mean, we don't need to wait for one to be finished before issuing the other request. So you can run independent parallel requests. What's the best way to do this? Well, actually, we saw the promises, and you remember the promise all, right? How do we know, actually, that all the fetches has been answered? So you got the answer for all the fetches? Well, actually, the fetch gives you a promise, right? So you just run the fetch, you get the promise, and you pass them to the promise all the promises, and the promise all will tell you when all the promises are solved. And then you process the content as you like. Or if they are completely independent, you just issue them, and then you have some code that will start being executed when the promise is solved, okay? This is just for convenience. I mean, in case you want to wait for all the promise to be solved, so all the fetches have a response, and you have the data in your JavaScript that correspond to the response to the fetches, okay? Like before, I want to show the list of the codes and the list of the students in the application, but I want to show them only when I have both, okay? I need to wait for both, okay? Otherwise, I could write code differently and say, well, when the list of students is present, just update the list of students, and vice versa, when the list of codes of courses is present, just update the list of courses. That's another possibility. It doesn't involve the promise all, because I don't need to wait for both to perform an action, okay? up to you, decide what to do. I mean, it depends on what you want to show, how you want to handle the interface towards the user. Okay? You want to have all the data and then show? Problem is solved. You want to update the data as soon as you have it? You don't need this mechanism. Just, I mean, separate function. Don't wait for the other fetch. Just have separate functions that run independent fetches. Okay? It's fine. Okay. Last bit of information I want to tell you, and then we will go to the example, a bit less boring. Okay? I mean, the fetch is very good. It's a very good API. I mean, it's the third API that we got inside the browser for doing these operations. I mean, you're quite young, but I mean, Google started using the first API that was named, I think, XML HTTP request, one of the first APIs that were able to perform asynchronous requests started from JavaScript code on the client side. But they were quite, I would say, messy to use, okay? And now things have evolved, and basically both the browsers, W3C and so on, have standardized this fetch approach. So just forget about the old ways of doing these operations and just use the fetch, which is pretty good function. Even though it has some limitation, that's why you find some libraries, in particular this Axios library, that might be useful in case you want to have advanced functionalities. For instance, the fetch has no easy way to interrupt the request. You made a request, you change your mind, you want to stop the request because you didn't get the answer from the server yet, or you're getting the answer, but you want to abort the operation. I mean, there is an object you can pass, and so it's quite complex mechanism. And some other libraries, they might give you better control on these aspects. For instance, you are downloading a lot of data. You are downloading 1 megabyte, 10 megabytes of data. You want to have a progress bar. Okay? There's no way of achieving it. I mean, there is a way, but I mean, it's quite complex to achieve it with a fetch. But with other libraries, they might expose an easier mechanism to achieve these behaviors. Okay? That's why libraries exist to perform the same, more or less the same functionality of fetch. For instance, this Axios, in case you really want to use it, performs automatic JSON conversion. It supports like a progress bar and stuff like that. Handles parallel requests in an easier way, and so on. Okay, so it's just a library that builds on fetch. Inside the library, they use fetch, or maybe even use something else for even much older browsers. Okay, I mean, you are not required to use this Axios. I've seen maybe five people each year that use this library, probably because at the exam, I mean, probably because they like it and they wanted to try it. I mean, fetch is more than enough for our purposes. We're not downloading gigabytes of data. We don't need the progress bar. And so, I mean, basically, all functionalities are already contained in fetch. Okay? And JSON conversion is really just an additional line. So, I mean, everything is fine with the fetch. Okay? And we don't typically need to cancel requests as well. Okay, so that's all for the theory parts of the slides. So let's have a look at an example in which we will test both the cross-site scripting attacks. So we'll have a look at these things like escaping, sanitization, what happens in case you have stored CSS attack. So I have something like this stored in the database, not really script, etc., because it doesn't render correctly, but I will show you something similar. And then we will test the content security policies as well, okay? So adding headers and so on. Okay, let's try. So everything is already on the website, right? So examples, which goes to the usual website, WA-Weeks, week 06. Okay, for us the 06 is the one with the Easter. And all the code is just here. I'll do small modification just to test different things now. So here there is both a client and a server. Okay, so a situation which is a bit different from what you will have to do at the exam. That we will start next week with the configuration that we will use for the exam. We will use a package that makes the configuration and prepares the client part, and then we have a server part which is separated, that is more or less what we see here. But here, just for simplicity, since we don't have anything like React ready to be run and so on, basically there is a server, so you recognize the usual index MJS that has, that has some APIs, okay? So import express, Morgan, use Morgan please in the lab. My colleagues say that few of you use Morgan. I mean, it's useful. It just gives you help you in debugging, okay? It's not mandatory, but again, there are advices. I hope you follow them. You create the express object, you define a port, you attach some callbacks to APIs. These are the usual API, questions, answers for a question, the one that we already saw during the course. And at the end, you start a server, app listen, no, the agent for us, not now. App listen, port, okay, listen, QA server listening on a certain port. So basically, we can install it, I think. Yeah, I already did it during the break, sorry. So npm install, I means install. Okay, so it's been installed. Where did it get the packages? Well, from the npm repository, but the list is in package.json, okay, as usual, okay. Okay, and now we start it. And nodemon, if we like, it's better. We use nodemon because it's so easy to forget restarting the server when you change a file. Okay, but node is fine. Nodemon, index.mjs. Okay, so QA server listening HTTP 3001. Okay, follow link. Let's see what happens. Okay, cannot get slash. That's fine. I mean, we probably don't have any, no, we have, I'm not sure. We, just try again, okay. Not found, I guess. Oh, that's generated by Express, I guess. So, index.mjs, we don't have any handle for slash. We have static, we'll come back to this, slash API questions, question ID answers, answers ID, post API answers, and so on. These URLs work, but a slash is not defined, okay? So just say not found. Just let's try to see get API questions, okay? Just see if it works. Slash API slash questions. Okay, good. Raw data. JSON, I mean, the browser is so convenient that it recognizes JSON. It provides us this tab so we can read the JSON in an easy way, but I mean, just for convenience, like the inspector here, okay? Headers, it was a GET request. Of course, it was run by the browser. If you type something in the URL bar, you press enter, you issue a GET request towards the server. You see the status code 200 OK in the response. No, that's a previous line. But then you have a response headers. You see content type application JSON and many other headers that, I mean, we are just ignoring at the moment. okay? And typically also in the future. Okay, so the server works, right? It runs. So at this point, I have a server with a lot of APIs, but actually I wanted to use an application, right? A client application. So I need to write some HTML code, some JavaScript code, and serve it from the same web server. How can I do it? Well, you remember that when we talked about Express, maybe you don't remember, I tell you again, you can define a middleware with Express static that says that everything that is in a folder /public, you see the folder here, will be served again below under actually a URL /static that you define here, okay? So if you say /static/index.html, we will get this index.html file from the server, okay? So let's try. So /static/index.html, okay? Enter. Oh, okay, we got the application. We got the hack as well, but I mean, that's another issue. So, in short, that's the application, right? So, if you look with the inspector, there is some HTML code, a head, body, and so on, okay? Body, yes, div, header, main, and so on. What is this stuff? It's the stuff we wrote here, index.html. This has been asked by the browser without any fetch. I mean, this is a browser request, initiated by the user. You type the URL in the bar. You clicked on a link, hopefully not on an email, but I mean, somebody gave you the link, or Google gave you the link, gave you the link, and you clicked on the link, okay? So you made the first request toward the server answered with some HTML. And this is the HTML that is sent back from the server to the client. And you can see it, by the way, network. Oh, no, well, you need to have the inspector open to debug the request. So I send it again. So the first one, right? Get localhost 3001 static index HTML, 200 OK, and the response row is just the HTML. Okay, the content, the static content we have in the Visual Studio Code. Okay, exactly this file. Of course, in this file we can do many things. As I said in the beginning, we can load CSS, we can load JavaScript from external website, from our website, and so on. That's indeed what we do. So let's have a look at the HTML. Head, okay, meta, I mean, viewport, we don't care. This is a comment just for later with the content security policy. But you see here, we load the Bootstrap, okay? Bootstrap what? Bootstrap CSS. Also the fonts, I mean, no, the icons, sorry, just for convenience. We load our file, style CSS. There is a very simple file, I mean, just to try. Where was I? Here. We load day.js, okay? And we load our JavaScript code, app.js. You remember the JavaScript code we developed last time? Create answer node, inner HTML, inner text, and so on, append child, etc. I mean, everything has been loaded by the browser. Because we declared everything here, oops, in the index. Okay? Yeah, something could be improved, maybe. We could, well, no, defer. Defer is already here. The CSS is fine, it's here. Yeah, the only thing is maybe we could have loaded this in a different way, but I mean, this is something I can introduce to you now, but I mean, we're going to forget this stuff. But so it's just in case you are developing your application by yourself and you want to load your JavaScript code. But when we have React, from next week, everything will happen automatically. Remember that when you load a script, you can also say type module, okay? And so in app.js, basically, you can use the module, ES6 module syntax, okay? You don't, actually, you actually don't need to use strict because modules are by default in strict mode anyway. And so, in short, just the way, we load the script as allowing all the functionalities for ES6 modules inside the browser. Just type equal to module, okay? Okay, but I mean, this is just the other part. Body part, it contains nav header, so I think it's this heap overrun. If you're not sure, like me, I mean, I don't remember. I'm old. I don't remember things so well. Just try, right? You have the inspector. Just click on the things. Okay. Header, nav, this is the nav, and so on. Okay, you can debug anything you have. Even on other websites, you open the Polito website, you can do the same. Actually, everything is happening on the client side inside your browser, so you can do whatever you want. Okay, you're not hacking anything. I mean, you're just inspecting how things work after you downloaded them from the website. Okay, so actually there is an header, okay, and the main containing a question, okay, so a paragraph with a question text and the author, and a table, okay, with the answers, right? Actually, the table is empty, not here. The table is empty. You can see it here as well, I think. Yes, you see, it's empty, right? But we are seeing something inside the table in the browser window. Why? Because the JavaScript has loaded something from the server, and then it has populated the content inside the browser window. So it has created new DOM nodes, so the table row, table items, and so on. And it created something to be shown inside the table, okay? So where did this happen? We have to look at the JavaScript code, okay? So JavaScript code is in app.js, I mean the main one. We only load app.js, and then app.js import other JavaScript code. That's fine. I mean, that's a normal way we operate with JavaScript, right? You remember the modules? We just separated the code in two different files, but APIs is for later. And so at load time, the main part is answer list. I wait get all answers. So here we get a list of all answers. We'll go into this function in a minute. Basically, it uses the fetch to load the stuff from the server. And then it creates the answer list. Okay? You can also, if you don't trust me, you can put console log answer list and look at the list here that has been loaded. And you look in the console in the browser. And create answer list is the code that we already saw last time. Okay, so it creates elements, td, and so on. At a certain point, it creates a tr element, table row, and creates the row, and then append the child, and everything is inserted in the DOM, so it's shown to the user. Good. So let's have a look at the get all answers, which is in the other file, api.js. Async function get all answers. Well, question ID just because I wanted a general function so I can load the answer for any question. Const response, await, fetch, URL plus / questions, question ID answers. Okay? So URL is http localhost 3001 API / questions / the question ID, which is 1, we passed 1, there's answers. So fetch, the browser has automatically issued a request, an HTTP request, GET request, because nothing else is said here, a GET request toward the server, okay? And then it takes the response JSON, and so on, and it returns something back to the caller. Okay, let's have a look at if this request is present here it is. You see, get HTTP localhost 2000 API request 1 answers. Okay, I didn't type it in the browser URL bar. Okay, it happened automatically through JavaScript inside the code in the browser. Okay, so the fetch is run. Browser asked the web server the information, it got the information, it made it available to the JavaScript environment in the form of an object. I think it was a list, in this case, an array, I think. So that's a request, no payload, okay, it's a get. Response, the raw response is the JSON, okay? You can even parse it and have a look that this corresponds to what is shown here, okay? So we have a sort of first actual web application working, right? I'm not sure we can define it as a single page application. For sure it has just one page. At the moment we don't have any other dynamic behavior. Well, maybe the vote, yes. Yes, we can, well, we come back later, okay? But yeah, we can say it's a single page application in the sense that we are not reloading a page, right? We are just working on the client to modify the score. We are not communicating them to the server yet, so it's really half application. Okay, so we load the first set of information is loaded from the server, but the rest doesn't really work. Okay, it works only on the client. You see, the number increases because we play with JavaScript, not because we communicate with the server. Okay, good. Let's come back to the interesting part, you know, the cross-site scripting, right? So here, response, question, response, JSON, return questions, map, and you can do whatever you want, what you are used to do in JavaScript, okay? This is an async function, so the return value is the value of the fulfilled promise. That's fine. Let's go back to app. We did await, so answer list is actually the value of the fulfilled promise. Actually, we didn't handle the situation in which there was no network connection, okay? You can try yourself. I mean, we don't have so much time, so I'm trying not to spend too much time on things that are not so important for the explanation, okay? But in the lab, let's try these situations, and we are there to help you, or at home, wherever you want. Okay, so now you might have noticed that when I first loaded the application, okay, HTML, okay, this alert, act the cross-site scripting, okay? What did it happen? Well, let's have a look at the response from the server when we loaded the answers, okay? You see here, this is the get localhost API questions 1 answers, the one we just saw. You see that the text for the item number 5 was IMGs, SRC, on error, alert, etc. Okay? Actually, this code is actually executed by the browser, right? Because actually we did a number of errors, right? Actually, no, that's a button with text, right? It's the second one. Yeah, it's here, right? You see? And this has been executed. Why? Because I'm not sure if you noted it, noticed it, but in the app.js, you see, we set stuff with inner HTML. First issue we have. Okay? If we set stuff with inner text, it doesn't work anymore. Because inner HTML says, okay, takes the string, parse it as if it is HTML, and so if it's a script, it gets executed. In this case, script doesn't work. That's why I didn't use the tag script, because we are in a table, and so you cannot execute a script putting it into a cell in a table. Okay? That's why I wanted to use this EMG and so on. So it's even more interesting because script is kind of trivial, right? Script hack. Okay, it's fine. But I mean, there are more sophisticated ways of achieving this result, right? So this is what we, what we have in the database. So img src slash, so the image does not exist. And we define on an event handler on error. When you have an error loading the image, you execute some JavaScript code, okay? And you can put the image inside the cell of the table, okay? So not so trivial, but I mean, the mechanism is the same. And so now you understand the slide we saw before. You remember we had to strip this on error attribute. Why? Because these things might happen, right? And the library that you use to do the sanification has to know all these things, and hopefully all of them. Otherwise, we risk that an attacker discover a new one. We are never sure that we got everything, right? Okay, so just make a modification up. So inner text, okay? Text, right? Save. So the server has restarted. I have node mode, so server has restarted. I restarted the application. You see, this time nothing happens because we were careful in writing the JavaScript code. And you see, of course, I mean, we cannot display an image. That's a limitation. We need to rewrite the code if we want to display images. Maybe we need to get the URL and not an HTML fragment in the JSON or something like this, okay? So that we control what's happening, and I mean, and the tag, the img tag, is created on the client side and not taken as data from outside and so on, okay? So I'm not saying it's impossible to display an image here, but we need to rewrite our code to avoid this potential issue, okay? Okay, so one thing. We go back to the inner HTML because it's the way in which we can demonstrate things, okay? Without this, I mean, at the moment I have no other ways of showing code executed when we don't want, okay? The other thing I wanted to show you is on the server side. You see that we allowed the people to use HTML tags in general. You see the I means italic, B means bold, okay? And you see that this is in italic, this is in bold, and so on, okay? Maybe in your application you want to allow a few tags to be used, okay? Like in a forum, I mean, you don't really want to write whatever you want, but maybe you want people to be able to use, let's say, a bigger font or a bold font and so on, because it's nicer, simply because of that. So a few tags might be acceptable for your application. But again, be careful. How did we manage these things here? I mean, so we need to allow to store these tags in the database. Otherwise, we don't have the functionality. If we strip the text, I mean, there's no bold, italics, and so on, right? So we need to allow it, but we need to be careful when we give things back to the user. So there's this API. Yes, you see, this is the API. API questions, ID answers. Okay? That's the callback being executed. So it goes to the database, it performs the query, so you select start from questions and so on. Okay? And you might want to check what you return. Instead of doing res, JSON, result, whatever it's inside the database, you might want to say, for instance, validator escape, right? I think we need to use the array. So just comment res JSON. So just modify the code. Okay, we start from result. Instead of returning a result, we run validator escape, okay, on each of the items. So let's try what happens. I think I saved. Yes. okay? You see what happens. Actually, we escaped the content. So the content is not executed by the browser anymore. If we go here and see what's inside. No, that's not good. That's an example. I mean, let's see what it was returned by the server. Yes, you see, less than ampersand LT semicolon and so on. Everything has been escaped, including the on error and so on. Remember the on error alert and so on. Indeed, it's not executed if you see no alert, right? Because it's just shown. It's not executed, okay? Let's just try what happens in case you want to keep the bold, italic, and so on. That was the purpose, right? So, in this case, just sanitize instead of escaping. Escaping means showing as it is, okay? Without risking being dangerous, okay? Sanitizing means allow only what is safe. So save, try again, okay? So you see the bold is there, the italics is there, the image is there. But let's see what came from the server. You see img src / no on error. The on error has been stripped by the sanitize function. That's the same example I had on the slide, exactly because so you can try the same example, okay? So in this way, we are able to interpret the HTML tags. Of course, I mean, this was a malicious tag, so you have no image to show. If it was an image created in a proper way and so on, it would show an image, okay, with the correct URL and so on. But the point is that you see that we sanitized what it came out from the database, making sure that we don't execute this code, dangerous code on the client. We have a problem on the client as well, okay? Don't forget, because you remember the inner HTML. Everything started because of the fact that we had this inner HTML on the client side, okay? But I mean, there are many points where you might have problems, and maybe you are not right in this part, and somebody else is right in that part, okay? So, I mean, security is most of the time is mitigation of problems. So you try to avoid problems in many parts of your application, and hopefully at least in one of the parts you prevented the problem from happening, okay? So, last thing I want to show you, I think, yes, a couple, but they are related, is, so let's leave the vulnerability here. So everything commented. Yes, save. So let's try it works. Yes, act. Fine. You remember the content security policy we talked before the break. We talked about before the break. Let's enable this content security policy. Okay. So I told you there is a library, Express CSP header. Okay, you need to import a little bit of symbols, when you define things, but these are just technicalities. Save. Okay. Now we load the application. No hack. Why? Because if you look in the console, content security policy, the page is setting blocked an inline style from being applied because it violates the following directive. Where style is blah 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 blah. Okay. Okay, good. And basically it says script source, okay? So the JavaScript code can be executed only if it comes from self, it means the same website. So it's an external resource like app.js, the other file, API.js and so on. Or we have to add the two websites that handles the Bootstrap and the JS, okay? If we don't add them, the browser sees them, it doesn't, I mean, I'm not sure if it loads them or not, but it doesn't execute them for sure, okay? You want to have inline scripting, it's fine. I mean, pretty dangerous, typically you don't want, but we can do it. Save, inline, okay, reload it, and this time we get act, okay? So the inline scripting is what you write in these attributes that can take event handler directly written in JavaScript, on error, on load, on click, on whatever, okay? Okay. This was about CSS, I think. Maybe I forgot to add something, I don't know. And you can have rules for JavaScript. Let's remove the inline. For JavaScript, for CSS, for fonts, even fonts may be dangerous, images and so on. Okay? Images, because you can have an image that says, well, write your password here, coming from another website and so on. Okay? Okay, so last thing. You don't have access to the web server. I mean, we have access, but let's pretend we don't have access. You remember that we have this section here, meta HTTP equivalent, so an header like it was an HTTP header. We can do exactly the same. So uncomment this, save, serve. Again, not act, okay? Why? Because script source, you see here, self was self, but it was not in line, okay? And this was inline code. If you go here, you see there is on error alert. It didn't execute because of the content security policy. And this was specified inside the HTML and not, so here, and not as an HTTP header, okay? So there's no header here in the response, okay? Content security policy. If we add it, so uncomment this, we can have both, I mean, but I mean just to be quick. Okay, we reload it, and you will see the response headers, content security policy. Okay, one is served by the web server, and the other is served, I mean, inside the HTML file, and the browser looks for both. Okay, now we have both, so it's probably not a good programming style. Okay. But because they can be conflicting, you need to decide which is the one that gets priority and so on. Okay? But so basically today we saw how many things can go wrong while you are programming in JavaScript by yourself, your web application, right? And in particular, this cross-site scripting attacks, that means tricking the browser into executing code that we don't want as application developers, okay? Many different systems and so on. We had the demo as well. And so try to think about all these potential problems when developing your web application, especially if you're storing HTML code, or you need to generate or execute some JavaScript code or create URLs and so on, all the unsafe sources that we say might be problematic in web applications, okay, when programming with JavaScript. basically all web applications. And most of the frameworks, React and so on, prevent most of the attacks, like cross-site scripting attacks, because they don't allow you to pass back to the client HTML code and so on that has not been checked by them, okay? So, I mean, showing something like this in React is much more difficult because, I mean, we cannot have a variable and just put it there and hope it gets executed. Here, we were able to execute everything because we had this inner HTML, which was pretty unsafe, right? But in general, remember that there are always new ways of how to say achieve these attacks, because browsers are quite complex programs, JavaScript applications are quite complex programs, and it's easy to get something wrong somewhere by yourself or even by some libraries that you are using. It's not maybe about you, but the libraries. And so we come back to the issue of the libraries, packages, and so on. Somebody has to check what you use with libraries and so on, and reject or prevent you from using libraries, new versions of the libraries and so on, until they checked everything seems okay. Okay? And I say seems and not is, because, I mean, being sure here in the security domain is always almost impossible, right? Because otherwise there will be no new attacks at a certain point, okay? So just try this example at home. We don't have a lab on this, okay? Because, I mean, it's just so complex to set up that basically I need to guide so much, and basically you're just trying an example that is almost ready. So I don't think it's worth having a lab on this. Next lab will be about React, but before that, on Monday, we start talking about React, okay? Okay, so unless you have questions or comments or anything, I think we can stop here for today. We will meet on Monday, 1 p.m., again in this room, and start React, so the last part of this course. Okay, thank you, and see you Monday.